Hey, good day, chemists. In this episode, to discuss some basic concept of chemistry. Basic constituents of matter is atoms and molecules. Let's start with definition of chemistry. It is the branch of science which deals with the study of composition, properties and interactions of matter. Now question is, what is matter? Anything which has mass and occupies space is known as matter. Like water, pen, pencil, book, anything that you see that have mass and occupy space is a matter. Physical states of matter. Matters have solid, liquid, gas, physical states. Plasma also, but we have discussed here only three: solid, liquid, gas. So discuss these states with their volume, shape and examples. First, solid. Solid have definite volume and definite shape. Example, book, pen, pencil. Another state is liquid. Definite volume, yes, it have definite volume. It do not have definite shape, because you pour liquid in a container, liquid occupies the shape of that container. Example, water, milk. Gas. Gases do not have definite shape and do not have definite volume, because it is occupies the space of container in which you put it, and also it do not have definite shapes and definite volume, because its volume changes according to environment or the container. Example, CO2, air, etc. Temperature and pressure effects on physical states. Solid, when heated, converted into liquids. On further heating, converted into gases. While gases, on cooling, converted into liquid. On further cooling, converted into solids. Classification of matters. Matters can be classified into two states: mixtures and pure substances. Mixtures are further classified into two subunits, that is homogeneous mixture and heterogeneous mixture, and pure substances can be classified as elements or compounds. So first we discuss about mixtures. Mixtures contains two or more substances in any ratio. That ratio is not fixed. And this ratios of components is not fixed, gives the property of mixture. Example, air, tea, etc. First, homogeneous mixture. Its components are completely mixed with each other and have uniform composition throughout the solution. Example, sugar solution, air, etc. Heterogeneous mixture. Its components do not have uniform composition throughout solution. Sometimes different components observed. Example, mixture of salt, sugar and sand and oil. So in the mixture of salt and sugar, it's not completely mixed, and in the mixture of sand and soil, it's not completely mixed. So this gives the property of heterogeneous mixture. Pure substances. Pure substances have fixed composition. Example, copper, gold, water, etc. Elements. It consists of only one type of particles. Example, atoms or molecules. Example, hydrogen, oxygen, gold, silver. So element consists only one type of particles, that is atoms and molecules. B. Compounds. It consists of two or more atoms to give a molecule of a compound. Example: carbon dioxide, water, NH3, ammonia, etc. Properties of matter. Matters have physical properties and chemical properties. Physical properties are those properties which can be measured or observed. Chemical properties are those properties in which chemical changes occur. Example of chemical properties is acidity, basicity, combustibility, etc. SI units. SI unit is International System of Units established by 11th General Conference on Weight and Measures. SIs have 7 fundamental units. Other units are derived from 7 fundamental units. SI table. SI table contain the 7 physical units, their symbol for quantity, and SI unit name and SI unit symbol. Base physical quantity is length. Its symbol is L, and units name, its SI unit name is meter, and SI unit symbol is M. Another base physical quantity is mass. Symbol for quantity is M. SI unit name is kilogram, and SI unit symbol is kg. Another base physical quantity is time. Symbol T. SI unit second, and SI unit symbol S. Another base physical quantity is current. Symbol I. SI unit name ampere. SI unit symbol A. Another base physical quantity is temperature. Symbol T. SI unit Kelvin. Symbol K. Another base physical quantity is amount of substance. Symbol for quantity is N. SI unit name is mole, and SI unit symbol is mole. Difference between these two is SI unit name mole, MOLE, and SI unit symbol MOL. Another base physical quantity is luminous intensity. Symbol IV, V in subscript. SI unit name candela. Symbol CD. There are some prefix for SI unit which we place in SI unit to change its amplitude. Multiple is 10 to the power minus 24, prefix yocto, symbol Y. 10 to power minus 21, zepto, symbol Z. 10 to power minus 18, atto A. 10 to power minus 15, femto F. 10 to power minus 12, pico P. 10 to power minus 9, nano N. 10 to power minus 6, micro M. 10 to power minus 3, milli M. 10 to power minus 2, centi C. 10 to power minus 1, deci D. 10 deca dA. 10 to power 2, hecto H. 10 to power 3, kilo K. 10 to power 6, mega M. 10 to power 9, giga G. 10 to power 12, tera T. 10 to power 15, peta P. 10 to power 18, hexa E. 10 to power 21, zeta Z. 10 to power 24, yoto Y. Now, what is mass? Amount of matter in object is known as mass. So 1 kg is equal to 1000 gram. Weight is equal to force on object by gravity. And formula for length is formula for volume is length into length into length, that is length cube. So 1 liter is equal to 1000 ml or 1000 centimeter cube or 1 decameter cube. Density is amount of mass per unit volume. Its SI unit is kg per meter cube. Temperature is the measurement of cooling or warming. Three scales for temperature is used, that is degree Celsius, degree Fahrenheit, Kelvin. Freezing point of water is 0 degree Celsius, boiling point of water is 100 degrees Celsius. Relationship between degree Fahrenheit and degree Celsius is as follows. Degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32, or Kelvin is equal to degree Celsius plus 273.15. Precision. Closeness of various measurements for the same quantity is known as precision, and accuracy is defined as it is the agreement of a particular value to the true value of the result, and significant figure is defined as meaningful digits which are known with certainty. Dear friends, these three definitions, precision, accuracy and significant figures, are very important in physical chemistry. So please learn it, understand it and apply it. Laws of chemical combinations. Law of chemical combinations. Law of conservation of mass. Law of conservation of mass. According to this law, matter can neither be created nor destroyed. Given by Antony Lavoisier in 1789. Law of definite proportion. According to this law, a given compound always contains exactly the same proportion of elements by weight, known as law of definite proportion or law of definite composition. It's given by Joseph Proust in 1754 to 1826. Law of multiple proportion. According to this law, if two elements combine to form more than one compound, the masses of one element that combined with a fixed mass of a small whole number, given by Dalton in 1803. Gay-Lussac's law of gaseous volume. According to this law, gases combine or are produced in chemical reactions. They do so in a simple ratio by volume, provided to all gases are at the same temperature and pressure, given by Gay-Lussac in 1808. Avogadro's law. According to this law, equal volume of gases at same temperature and pressure should contain equal number of molecules, given by Avogadro in 1811. Now, Dalton's atomic theory. Matter consists of indivisible atoms, means these atoms cannot be further divided. All the atoms of an element have identical properties, that is same properties. Atoms of an element have same mass, while atoms of different elements have different masses. Compound formed when atoms of different elements combine in fixed ratio. Chemical reactions involved rearrangement of atoms. Atomic mass unit is equal to 1 by 12th mass of one carbon-12 atom. Molecular mass is equal to, it is the mass of atomic masses of the elements present in a molecule. Mole is, it is the amount of substance equal to Avogadro number, that is Na is equal to 6.023 into 10 raised to power 23 atoms per mole. Molar mass defined as mass of 1 mole of a substance in gram is known as molar mass. Mass percentage of an element is equal to mass of that element in compound into 100 by molar mass of the compound. Empirical formula: it is the simplest whole number ratio of various atoms present in a compound. Molecular formula: it is the exact number of different types of atoms present in a molecule of a compound. Dear friends, you can obtain these notes from our website www.chemistrynotesinfo.com, or you can download PDF notes of this chapter from our website or Telegram channel Chemistry Notes Info. Now, concentration expression methods. Mass percentage is equal to mass of solute divided by mass of solution into 100. Mole fraction is if a substance A is dissolved in B, then their number of moles are Na and Nb respectively. Then mole fraction of A is equal to number of moles of A divided by number of moles of solution. So Na divided by Na plus Nb. Mole fraction of B is number of moles of B by divided by number of moles of solution. Then Nb is equal to Nb divided by Na plus Nb. Molarity: number of moles of solute divided by volume of solution in liter. Dear friends, you can also visit our website to get complete chemistry notes of any class of any chapter from our website www.chemistrynotesinfo.com, or you can solve quizzes related to these chapters and also download videos or watch videos, participate in quiz competitions organized at our website and Telegram channel. So do visit our website and subscribe our Telegram channel. Thank you to listening this episode.